What is gravity?
You have no idea. Okay, next question.
Wow.
No, here's the difference. We can describe gravity. We
Okay.
can say what it does to other things. We can measure it, predict with it. But when you start asking, like, what it is, I don't know. I don't know. I don't know.
So did I accidentally ask a deeper question than I meant to?
Yeah, no, you were meant to ask deep questions.
Apparently I was.
In life. So to say, what is it? I think Einstein, in an Einsteinian answer, we would say gravity is the curvature of space and time. And objects will follow the curvature of space-time, and we interpret that as a force of gravity. That's probably the best answer I can give to a what is gravity question, or why is there gravity. That's the best I can do there. I think that's a good start. And I can also say that Einstein noted that matter tells space how to curve, space tells matter how to move.
Say that again.
Isn't that beautiful?
It is. No, I want to get that. I
Yeah,
like that.
so
That's a t-shirt.
matter and energy will curve the fabric of space.
Okay.
And it's that curvature that tells other matter how to move in the curvature of space itself. And so Einstein juxtaposed those in a poetic phrase where he said, matter tells space how to curve, did I get that right? Yes. Matter
I wouldn't
matter
know.
tells space how to curve, space tells matter how to move. It's beautiful.
That is beautiful.
It is beautiful.
It sounds like the opening to a dance lesson. And we begin.
So that is your co-host privileges.
Thank you
for a first question.
So much.
That warmed up the crowd.
It did.
All right, so they talk about warp space-time or whatever, trying to explain gravity. Y'all can pause the video and read the definition right here real quick. But in this next clip, just watch this fucking circus act right here.
On the sail. And so you put matter and it warps space-time. And so if I have another object, it also warps space-time. They feel that and they're attracted to each other. And so that's Einstein's picture of gravity. Objects warp space-time, feel that curvature, and move accordingly.
So obviously they saying gravity is space warp time bent by mass. And that's what they're using here with the spandex trampoline they got right here. It's the blue trampoline represents space warp time, and obviously he's going to set a heavier mass within the center of it to show how items are drawn to it. Personally, this is just look like it's a fucking magic trick, and everybody gonna fall for it. If you wind up watching the whole video, it's 22 minutes long or something like that. I might put it in the description box, I might not, but at the end of the day, y'all can go ahead and check it out, be the judges of it. But honestly, it's bullshit to me. I will go into deeper depth of why it's bullshit, but I might set up for another video. I want to just crank this out and, get my point across. So I'm going to go ahead and let y'all be the judges of it. Just listen to how you break this shit down.
Mass. You're right there. On that. You have more mass, it's going to bend space-time more. And so if you have objects here, they are going to respond to that, right? And so you put something there, now it's attracted. Now, in reality, that big mass would feel the warping of space-time by the marble too, right? It would move a little bit, but we usually ignore that. The Earth makes the sun move a little bit, but it's so small you can ignore it. The moon makes the Earth kind of wobble around a point 3/4 of the way from the center of the Earth. We usually don't account for that when we're looking at satellite motion. Well, instead of just letting go of one, what if I give it a sideways push? Now it orbits. Now it's losing energy, which wouldn't happen in the solar system, right? Not noticeably. There's some perturbations from other planets and things, but this one does lose energy and spirals in. If I don't push it as hard, it will do an ellipse for a while anyway. And let's put some more here.
So, You see, it's gravity that packs things together. Things like atoms, they pack like little balls. And then planets and stars, they're like big round balls. Wow. Can you guys think of anything else that's big and round?
How about a big round of applause?
All right, bunch of clowns. Anyway, the only thing he's about to prove in this next clip is density, which they don't never really talk about. And yeah, that's the only thing I'm about to point out right here.
The pull of gravity isn't so strong that we can't raise our arms or anything, but it does pull on everything all the time. So if we're standing on the Earth's surface, it pulls us down toward the center of the Earth. Now we can test this. This is an old idea, but a good one. Watermelon. Carton of sour milk.
All right, one of the last things I'm gonna leave y'all with is buoyancy, the ability or tendency to float in water or air. This is our gravity to us of the flat earth. This is what we believe is why people don't fly off the earth. And it's not because we believe it, it's scientific fact as well. So I'm gonna leave y'all with this breathtaking image right here. And y'all just tell me, you know what I'm saying? Let me know y'all thoughts. Do the sun really look like it's 93 million miles away? The effect that this sun is about to have on these clouds right here, this is just breathtaking. I'm going to shut up and let y'all just really soak this image in. It don't look like it's 93 million miles away to me, but y'all be the judge. I'm out.